Very good morning, friends. So this is a short video about ECG. We all know what is ECG. ECG is the abbreviation of electrocardiogram. So as the name indicates, electro means it's an electrical signal, cardio means it's art, and gram is recording. So it is a recording of electrical activity of the art. Electrical activity of the art. We all know what is the main functioning of the art. Okay, so basically if you take our art, so consider this as your art. Your art is having 4 chambers. Okay, so the topmost chambers are called as atrium. The bottommost chambers are called as ventricles. Okay, so you have right atrium, left atrium, right ventricle, left ventricle. Okay, so this is how your art is there. Okay, and on all the chambers you will have a valve. Art valve is there. Okay, so the right atrium actually accepts all the impure blood from the body. All the impure blood comes via the veins. Okay, so particularly it is called as inferior vena cava and superior vena cava. It receives all the impure blood into the right atrium. The right atrium then pumps this impure blood into the right ventricle. Okay, from right ventricle it moves to the lungs. And at the same time the purified blood, that is purified in the sense, what I mean by purified is oxygenated blood returns back from the lungs. This purified blood enters into the left atrium. Again from the left atrium it is pumped into the left ventricle. From the left ventricle it is pumped to the entire body. Okay, this is the mechanical activity of the art. The very beauty of this particular mechanical activity is, you can see this, these two atrium act synchronously. That is, the right atrium gets the impure blood, at the same time your left atrium gets the pure blood. So both these will act like a pump and pump the blood to the second stage. So right atrium will pump the impure blood, left atrium will pump the pure blood. Again, these two ventricles, even though they are isolated, they will function in a common manner. So the right ventricle will pump the blood to the lungs, left ventricle will pump the blood to the body. Okay, so this is a complete physical activity. Now the very beauty of our body is, for all the physical activities to coordinate with the physical activities, it also has some electrical impulses. Now we'll take our art itself. If you see the operation, first your atrium contracts, then your ventricle contracts. Okay, to coordinate with this action, okay, we have a particular kind of electrical signal that originates at this point. This is called as the point of origin. Okay, this is your atrium. Point of origin is called as SA node. This particular thing is called SA node. So SA node is called as sinoatrial node. Sinoatrial means it is starting. Sino means starting. So here the pulse originates. So initially, that is the point when your atrium is filling with the blood. Now once the blood is filled, okay, so at this point the impulse travels from right atrium up to this point. Okay, so it just conducts all over your art muscles. As it transfers your art muscles, this impulse or the excitation will give the required energy for your atrial muscle to contract. Can you see the thing? Initially when the impulse was at this point, that is the SA node, that is the time when the blood was filling in the atrium chamber. Now when the impulse travels from the SA node to this point is called as AV node. This point is called AV node. AV node is atrioventricular node. Okay, so it is in between atrium and ventricular, so it is atrioventricular node. So by the time it travels from SA node to AV node, this causes the compression of your atrium muscles. Thereby your atrium muscles push the blood into the ventricles. Now this AV node actually its main purpose of this node is it's a delay point. It's a delay point. It gives some delay. Okay, it gives some delay. Thereby the impulse is getting delayed. This is mainly for, you have two pumps. Okay, so you have a first pump over here and you have a second pump over here. For the synchronization between the two pumps, we provided delay. So the AV node acts as a delay node. Okay, again from AV node the impulse travels via the ventricles. By this time the impulse travels via the ventricle. What is the equivalent physical action is, your ventricles will contract. Particularly the role of left ventricle, it has to pump the blood to the extremities of the body. So it will be with greater amplitude. Okay, so from here the impulse will be traveling to the so here this area is called as bundle block, and from there it will be traversing to the fibers that cover the heart. They are called as Purkinje fibers. Okay, so you can see that your signal travels all the way through the heart in correlation with the mechanical activity. So this is the same thing we can just represent as a signal. Okay, the point at which it originates at your SA node, I'll just put it like this. Again from this point it travels to this point, that is SA node to AV node, which cause your atrial muscles to contract. So that impulse put together, I can draw it as a wave like this. And at this point, that is AV node, which acts as a delay, will provide a small delay. Okay, and after this delay, this has to travel via the bundle block and the Purkinje fibers. Okay, that will cause your ventricle muscle to contract. So since the ventricle muscle has to contract so much so that blood is pumped up to the extremities, the amplitude of this signal is great. Okay, so now you have this signal, then slowly your ventricle muscles will relax, you'll have some impulses, then your Purkinje fibers will relax, then you'll get your final ECG waveform. Okay, so this is your ECG waveform. So this is normally given by the term P, this is Q, this is R, this is S, this is T, and this is U. So P is mainly due to contraction of the atria. QRS is mainly due to contraction of the ventricle, relaxation of the atrium. T is due to relaxation of the ventricles, and U is due to relaxation of the Purkinje fibers and other fibers surrounding your chamber of the heart. So this is how you get your beautiful ECG line. Okay, this ECG waveform indicates the electrical activity of the heart. Thank you.